graphical inequalities. Here we are looking at x, y axes, and we have three different inequalities. X is less than or equal to 6. Now what I want you to think about when we're plotting these lines is what would the line of x equals 6 look like? So this is when the x coordinate is always 6. So you could think of this as making up some of your own coordinates, or we think, okay, where is x always equal to 6? That is here. So we are looking at perhaps 6, 1, 6, 2, etc. So we're going to join those points together. And we're going to do this with a solid line because it's an or equal to. So just to note, if it's less than or greater than, you draw your straight line with a dotted line. So this is the line of x is it's the line of x equals 6. We'll come to the inequalities and what we do with those shortly. Similarly, the line of y equals 2, that's where the y coordinate is always 2. So we head to the y-axis, minus 1, 2, minus 3, 2, 3, 2. So the y coordinate is always 2. And we go in with a solid line because it's or equal to. So that red line is the line of y equals 2. Next we need to draw the line of y equals x plus 1. My advice is to always draw a table of coordinates if you're ever unsure, and just pick 3 coordinates, 3 values of x. And we substitute in. Y is equal to x plus 1. So when x is minus 2, we add 1, that's minus 1. 0 add 1 is 1, and 2 add 1 is 3. And we plot those coordinates. Minus 2 minus 1, 0, 1, and 2, 3. And we join this up with a straight line and we continue it across the axes. And this blue line is y equals x plus 1. Now to shade the region, we need to consider all of the inequalities. So x is less than or equal to 6. So my purple line, I'm looking at shading to the left-hand side of this line. Y is greater than or equal to 2, so I'm going to be shading above the red line. And y is less than or equal to, so I'm going to be shading below the blue line. So where is the region that satisfies all of those inequalities? It will be this section here. We're above the red line, we're to the left of the purple line, and we are below the blue line. That's the only place on this axis where that is all true. Let's try again with some more difficult inequalities. Starting with y is greater than or equal to minus 1. So we can think of our coordinate method, think of an x coordinate, and the y coordinate is always minus 1. So where the y coordinate is always minus 1 is here. We go solid line because we are or equal to, and that's the line of y equals minus 1. Next up is y equals 4 minus x. So let's go in with our table of coordinates for this one. Minus 2, 0, and 2. So 4 minus minus 2, be careful of those signs, that changes it to a plus, which is 6. 4 minus 0 is 4, and 4 minus 2 is 2. So what we've done there is we've generated some coordinates which we're now going to plot and join together with a straight line. We label y equals 4 minus x. 1 to go. Table of coordinates for y equals 3x minus 1. Again, pick some random coordinates. We can go -2, 0 and 2. So what we've got here is y equals 3 times -2 minus 1. That's -6 minus 1, which is -7. 3 times 0 is 0, minus 1 is -1. 2 times 3 is 6, minus 1 is 5. So let's plot these. 2, 5, 0, -1. Join that up. Continue that straight line. Y equals 3x minus 1. Now we need to shade the region. Be careful for just spotting the region that satisfies them all. You always have to double check with the shading above or below the line. So the blue line, y is greater than, so we are going to be shading above the blue line. Y is less than or equal to 4 minus x, so we are going to be shading below that red line. Y is less than 3x minus 1, so we are going to be shading below the purple line. Where's the region where all of those shading areas meet? That is this area here. We will shade this, and that is our final answer.